Hi there. We talked today in class about how to tell whether a function as exhibited in a table is a linear function or an exponential function. And to do that, we're going to be looking at our change in y specifically, because I notice here, for example, in the first table, that my change in x all the way across is +1, 2 to 3 is +1, 3 to 4 is +1. Same with the second table. In both of these cases, my change in x is constant. So I'm going to be looking at my y. In the first table, my change in y, -3 to -2 is +1, -2 to 0 is +2, 0 to 4 is +4, 4 to 12 is +8. And I notice that my y is not growing at a constant rate or shrinking at a constant rate. I'm adding 1, then 2, then 4, then 8. And so it's not going to be a straight line, it's not going to be linear, because if it was linear, a straight line, it would have to have a constant growth, a constant rate of change. And so then my next step is going to be to look at what's the relationship between these differences that I've found. What happens to get from +1 to +2, +2 to +4, +4 to +8? And in each of these cases, I notice a pattern of ×2. That ×2 is called a common ratio, and it's our indicator that this function is an exponential function. So again, exponential functions are when you've taken the difference, found either the addition or subtraction that's occurred between my y's, and then look at that addition-subtraction piece and see, do I see something being multiplied the same between each, or divided the same between each? In this case, I'm timesing by 2, but it might have been divided by 2. Okay, so with this second table, when I look at -2 to 1, 1 to 4, 4 to 7, 7 to 10, to get from -2 to 1, I added 3. Same with 1 to 4, same with 4 to 7, and same with 7 to 10. And there's my common difference. So common ratio is exponential. Common difference is linear. And there's my answer.